Welcome back to Math with Miss Murthy. Hopefully, second time's the charm, and it actually does the recording. Last time it showed me that it started recording, but sometime in the middle it stopped. Anyways, today's lesson is lesson 5.7. This is the last lesson of this chapter. This is lesson 5.7, equivalent algebraic expressions, and this begins on page 315 of your textbook. As usual, we'll do a quick warm-up, and I'll pause the video for your warm-up. Pause this right here, work on the problem, I'll share the solution. And there's the solution for those expressions. Let's finish up our warm-up. And the solution. All right. Here are the mathematical content. Pause the video to watch these, to read these. Standards for mathematical practice. And let's go. Our lesson goal today is to identify and generate equivalent algebraic expressions. Guys, I forgot to mention this earlier in the video. We're going to keep going till we hit about the 15-minute mark. I don't think we are able to finish up the lesson today. We will split this up into two parts, and we'll finish up the second part in a separate video. Okay? So our goal is to identify and generate equivalent algebraic expressions. Equivalent expressions are expressions that have the same value. Algebraic expressions are equivalent when they have the same value, no matter what value you put in for the variable. You substitute for the variable. And you can generate an equivalent expression by applying the properties of operations to an expression. Let's look at some of the properties. The first one we're going to look at is the commutative property, which states the order in which numbers are added or multiplied does not change the sum or the product. And you can see some examples here with both numbers and variables. For the variables, you can see a plus b is going to be the same as b plus a. This is just restating the property. And a times b is equal to b times a. You could even rewrite this as ab equals ba when we write the product. Let's review our associative property, which states the order in which numbers are grouped when added or multiplied does not change the sum of the product. And you can see some of the examples of numbers here. I'm just going to restate it in variables at the bottom. A plus b plus c is the same as a plus b plus c, or a times b times c is the same as a times b times c. A quick review of the distributive property, which states to multiply a sum by a number, we multiply each addend by the number outside the parentheses. An addend is one of the two or more numbers that you're adding to get the sum, right? You see some examples here. Again, we're going to go over this with variables. We can state a times b plus c is a times b plus a times c. And this can also be written as ab plus ac. Similarly, with subtraction, we have a times b minus c is equal to a times b minus a times c, which could also be written as AB minus AC. Moving on to the last property that we're going to be looking at. This, my friends, is on page 316.
Pablo Miski, please head to the 7th grade loop. Your ride is here.
As you can see, this is right after school.
Please head to the 7th
Our
grade
identity
loop.
property states the sum of an addend and 0 is the addend itself. And the product of a factor and 1 is the factor itself. You see some examples with numbers here. And I can restate it with a variable saying a plus 0 is equal to a. And a times 1 equals a. So let's look at how we use the properties to determine whether or not 4 times 2x plus 3 plus 5 and 4x plus 3 plus 5 are equivalent. So we're going to simplify the expressions and draw a conclusion. Let's look at this first one on the left, first expression. 4 times 2x plus 3 plus 5. When we apply distributive property, we see that's 4 times 2x, which would give us 8x, and 4 times 3, which gives us 12, plus 5. And then we apply the associative property to regroup the constants, which gives us 8x plus 12 plus 5, or 8x plus 17. When we take our second expression, this is 4x plus 3 plus 5. I would just apply, in this case, I'm only going to apply the associative property, which gives me 4x plus 3 plus 5, or 4x plus 8. And you can see that these two expressions are not equivalent. So because the simplified expressions have different terms, they will never have the same value. Therefore, the expressions are not equivalent. We're going to look at another example where we determine whether or not 8 plus 3n plus 2 and 3 times n plus 1 plus 7 are equivalent. Let's take a quick look. Let's simplify 8 plus 3n plus 2. I'm going to apply commutative property to regroup. That gives me 3n plus 8 plus 2. I enclose these within parentheses to apply the associative property, which gives me 3n plus 10. Again, let's take the second expression. 3 times n plus 1 plus 7 gives me 3n plus 3 plus 7. I now apply my associative property to give me 3n plus 3 plus 7, which is 3n plus 10. And as you can see here, guys, these two expressions are the same. They are equivalent. Just as I said, because the simplified expressions have the same terms, they will always have the same value, so the expressions are equivalent. Let's think about it for a moment. Are the expressions that are written before and after a property is applied equivalent? Think about it for a minute. Write your answer down and I'll discuss this with you. Yes, they are equivalent because the properties applied are only used to simplify the expression and they do not change the value or alter the expression.
Mr. Tesler and Mrs. O'Mara, please call front office. Mr. Tesler and Mrs. O'Mara, please call the front office.
Sorry for the interruption, guys. Again, let's move on. This example 1 is on page 317. We're going to use the properties of operations to determine whether or not 3 times x plus 7 plus 2 and 5 plus 3 times x plus 6 are equivalent. First of all, think about it. What determines whether two expressions are equivalent? We'll talk about this in class, okay, when we review. Let's take a look at our example. We're going to simplify the first expression. 3 times x plus 7, that gives me 3x, plus 3 times 7 is 21, plus 2. Apply your associative property, 3x plus 21 plus 2, which gives me 3x plus 23. I'm going to now evaluate the second expression. 5 plus 3 times x plus 6, which gives me 5 plus 3x plus 18. I rearrange them using commutative property, 3x plus 18 plus 5, which gives me 3x plus 23. Therefore, and both of these, as you can see, evaluate to 3x plus 23, so they are equivalent. Now take a moment to think about this. What are some expressions that are not equivalent to 3x plus 23? Any examples? Well, I can think of one. 4x plus 23 would not be equivalent. Or if I chose 3x plus 11, for example. Now solve this check problem on your own. Pause the video here as you solve the check problem and I will show you the solution in a moment. There you go. These two expressions are equivalent. We're now going to look at how to determine whether y plus y plus y and 3y are equivalent using substitution. Guys, we are moving on to page 318 over here. So let's, first step 1, right? We evaluate the expressions for the same value of the variable. So let's evaluate each expression when y is 0. On one side, you can see I have y plus y. When y is 0, that evaluates to 0. On the other side, I can see 3y is 3 times 0, which is also 0. So these are both equivalent when y is 0. Let's try a different value. We repeat it for y equals 5. The left side expression evaluates to 5 plus 5 plus 5, which is 15. And on the right side, you have 3 times 5, which is also 15. So based on the substitution...
If you are not a Thornton Middle School student, please exit campus. If you do not currently attend Thornton Middle School, you need to leave campus. Thank you.
Sorry, guys. Again, let's draw our conclusion. Based on substitution, the expressions appear to be equivalent. So if you continue substituting additional values of x, you'll see that the expressions will always be equivalent regardless of the value of the variable being substituted. So let's talk about it. Why is it important to substitute more than one value into an expression to help determine equivalency? Pause the video here, write your answer down, and I'll discuss my reasoning in a moment. So it is possible that two expressions could show the same value for a particular value of the variable, but not for every value of the variable. For example, 2x plus 1 and 3x plus 1. When x is equal to 0, this evaluates to 1 and this expression evaluates to 1 again. But when x is equal to 1, my first expression will evaluate to 2 plus 1, 3. My second expression evaluates to 3 plus 1, 4. As you can see, they're not equal for every value. Let's look at determining whether 5 times x plus 4 and 5x plus 4 are equivalent expressions using substitution. Again, this is on the bottom of page 318. We're going to solve this on two sides. Let's see 5 times x plus 4. When I substitute the value of x equals 0, I get 5 times 0 plus 4. That's 5 times 4, which is 20. On the right side, I have my second expression. 5x plus 4 is 5 times 0 plus 4, which gives me 0 plus 4, 4. And as you can see, these two are not equivalent. Let's use substitution to determine whether or not 2x plus x and 4x are equivalent. So we're going to draw our table, write our expressions on both sides, and we put our x equals on the middle so that we can evaluate them side by side. Let's see, on the left side I have for x equals 0, that gives me 2 times 0 plus 0 plus 0, which is 0. And on the right side I have 4 times 0, which is 0. These both are equivalent. When I substitute x equals 1, you can see that I get 2 times 1 plus 1 plus 1, which gives me 4. On the right side, that's 4 times 1, which is also 4. And when x equals 2, I get 2 times 2 plus 2, which is 8. On the right side, for 4x, I get 4 times 2, which is 8. As you can see, for multiple values, these expressions evaluate to the same. So I can determine that these are both, I can conclude that these are both equivalent. So as you can see, when x is replaced with different values, the results are the same for both expressions. So they are equivalent. Now, try this. Try substituting 3 more values for the variables, and what do you notice? You'll notice that no matter how many values you substitute for the variable, the expressions are still equivalent. Pause this right here, solve this check problem on your own, and I'll share the solution in a moment. These expressions are not equivalent. Now let's look at example 3 on page 320. I'm going to draw lines to separate these to make it hopefully a little easier to read. Whoops. All right, so on my left side I have half x plus x squared plus half. On my right side I have half x plus 3x squared plus half minus x squared. So when x equals 0, my first expression evaluates to a half, while my second expression also evaluates to a half. They both are equal. But when I substitute x equals 1, my expression on the left side is half times 1 plus 1 squared plus half, which gives me 2. Whereas my right side is half plus 3 times 1 plus half minus 1, which gives me 3. So these two are not equivalent. And again, when I substitute x equals 2, I get 5½ for one expression, 9½ for the other, so they are not equivalent. So based on substitutions, I can see that while it is equivalent for one value of x, it's not equivalent for all values of x. Therefore, I can determine that the expressions are not equivalent. So pause this video here and solve this check problem on your own, and we'll come back in a minute. There you go. In this case, these expressions are equivalent. As pause and reflect on this on your own, did you encounter any difficulty when you use substitution? And what are some important things to remember as you progress through this lesson? And we'll review this in class next time. I just want to do this combining really quick, and then we'll stop. So we'll do just page 321 and 322. So an expression is in the simplest form if it has no like terms and no parentheses. So all like terms should have been combined. So you can use the structure of an algebraic expression to combine like terms and write it in the simplest form. When you have a expression with only constants, such as 5 plus 2, you can combine these terms, like you see here with my bar diagram. I have 2 over here and 5 over here that combine to 7. Sometimes you have an expression with like terms, like 3x and 5x, which means you have 3 groups of x and 5 groups of x, which I can combine to get 8 groups of x. Or rather, I can represent that as 8x. We can also use algebra tiles to model and simplify an expression that contains like terms. So to model the expression, let's see, 2x plus 4 plus 3x. I'm going to play 2x tiles, 4 1 tiles, and 3x tiles. Now I'm going to regroup them to combine these x tiles together. That gives me 5x tiles and 4 1 tiles. So my simplified expression is 5x plus 4. Now let's look at how to simplify x plus 5x plus x. I have 1 x tile over here, I have 5 x tiles over here, and 1 x tile over here. When I combine them, I get 7 x tiles, which I can express as 7x. Now we can also use the distributive property to combine like terms. So this allows us to simplify by adding or subtracting. So I have 3x plus 5x. Now you can see the factors of this are 3 and x. The factors of this are 5 and x. So if I take out the common factor x, I'm left with 3 plus 5, which is x times 8, which is nothing but 8x. I want you to think about how you can use distributive property to combine like terms for the expression 2x plus 3x squared plus 6x squared. Now let's do this. Let's combine our like terms first of all. I have 2x plus 3x. And then on the other side, I have 3x squared plus 6x squared. My common term here is x. So I can use my distributive property to say this is x times 2 plus 3. And here, I see that the factors of this are x squared and 3. This is x squared and 6. Now again, 6 can be expressed as 3 times 2. So I see that both 3 and x squared are a common term, the common factor. So I can express this whole expression as 3x squared times 1 plus 2, which gives me 3x squared times 3, which is 9x squared. Or I could have just done x squared as the common factor and 3 plus 6, which also gives me 9x squared. So my final expression is going to be, well, this was 5x. My final expression is 5x plus 9x squared. All right, guys, pause and reflect on this. How did your prior knowledge of like terms help you to understand the concepts in this learn? So we'll stop this right here and we'll pick this back up in our next lesson. Thank you. Bye-bye.